Okay, so now we're going to look at the CT from 2021. I'm just going to run you through each of the questions and how to tackle them. Let's start on the first page. We're rounding 185, got to round it off to the nearest 10. Okay, so we're looking here, so this number's in the 10, the 8. The next number is a 5, so any number that's a 5 or bigger, we have to round up. So therefore 185 will get rounded up to 190, okay? This question, 4,142, nearest to the nearest, rounded to the nearest 100, so the ones in the hundreds here. The next number is a 4, so it's less than 5, so we're rounding down, so that becomes 4,100. Okay, now, the common mistake with this one is kids will round off to a 4,000, okay, because they're just rounding to the nearest 1,000, but you've got to know where it's indicating you've got to round to. Okay, 124 multiplied by 12, we're expecting you to put that in that vertical format, 124 multiplied by 12. And as always, I'm lining up my numbers here because it's just good mathematical habit to do that. Okay, so it's 2 times 4 is 8, and I'm writing my 8 down, so I'm creating a nice straight column there. 2 times 2 is 4, and 2 times 1 is 2. And then I'm multiplying by 10 here, so I'll put a 0 down here because I know it's going to end in a 0. 1 times 4, 1 times 2, 1 times 1, okay, and then I'll just do some basic addition here, 8, 4, and 1, nice and straightforward there. Make sure you line everything up. And finally, we've got 195 divided by 15, so we want to do that just as a short division, 15 into 1, 9, and 5, okay, and I'll have a bit of space here to do some decimals if I get to that point. So 15 goes into 1 0 times, so I'll put a 0 here, that creates a placeholder so I don't get the place value incorrect. 15 into 9 goes 1 time, okay? 15 from 9 leaves 4, so I'll put a little 4 here, so that creates 45, and then 15 into 45 goes 3 times, so my answer for that is 13, okay? There's no need to rewrite that somewhere else on your page because that just increases the chance of you making an error. Okay, so question 3 on the paper takes us into the land of BODMAS, okay? So my advice is always on your page is to record BODMAS on your page, and that way you can refer to it as a visual to help you work these questions out. So here, simply just moving left to right. Now, a couple of ways you can tackle this. I tend to do 3 times 6 and put the 6 up here as a place, as a note rather, and then I just do the 6 plus 7. But you could rewrite it if you want to do 3 times 2 is 6 plus 7, and then do the final answer of 13 that way, okay? The second one is a bit more complex because you've got to really consider BODMAS here. You've got addition, multiplication, division, and you've got index form here. So we want to make sure that we do the multiplication and division first, okay? So we want to rewrite this question. 3 plus 5 times 4 divided by, work out the powers, 2 squared is 4, okay? And then we do it left to right in terms of BODMAS, okay? So we do the 3 plus last, 5 times 4 is 20, divided by 4, okay? And then 3 plus 20 divided by 4 is 5, 3 plus 5, and then that equals 8, okay? Okay, now this one asks us to do a question in what we call expanded form, okay? Now, it literally means what the word indicates, it's expanded, so you're making something bigger. So just think of the 2 to the power of 3. Here, we're not after the answer necessarily. At this point, we're after the expansion. So what we want to see is 2 times 2 times 2. That there's 3 2s, okay, like this. Okay, and then we find the answer. So we expand it, and then what we call evaluate. So we find the answer. 2 times 2 is 4. That gives you an answer of 8. Okay, so a question like that, it's worth 2 marks. If you just go from here to the answer, you'll only get 1 mark. So just make sure you read the questions quite accurately. Okay, so here we're looking for the lowest common multiple of 2, 3, and 5. Okay, so we've got 2, 3, and 5. Now, you can do this across your page as well, but obviously I'm doing it down the page because my board goes down longer, okay? So it's 2, 4, 6, 8, 10, and 12, okay? And 3, 6, 9, 12, 15, 18, and So you can see here that we're looking for the lowest common multiple, okay? And we're not getting to any of them yet, okay? So typically if you get to this point, the easiest thing to do is look at the three numbers that are there and multiply them. 2 times 3 times 5, okay? And that'll give you 30. And so you can see here 30, and so 30 is going to be just down here a little bit, and 30 is going to be down here a little bit. So 30 would be our lowest common multiple, okay? And I suppose look at that is that if it's none of the numbers before 30, okay, that it's a common multiple. So it's not going to be 25 because that's an odd number and we've got a 2. So they're automatically out. So the only numbers left over are 20 and 10, okay, and neither of those are multiples of 3, so it has to be 30. Okay, so highest common factor, okay, so we can use factor trees to do this. So we can have 5 and 2, okay, and here we can have 2 and 15, and then that gives us 5 and 3. So that gives us these as factor trees, okay. 5 times 2 times 3, and 5 times 2 times 3, and we can see that those two are in both sets of factor trees, and 5 times 2 is 10. So therefore 10 is the highest common factor for those two particular numbers, okay? The other way you could do it, you could have listed all of the factors for both numbers, and you could have just circled it from that one as well. But seeing as we've done factor trees, it was worth demonstrating how that works. Okay, so this question here would have Michael, Chelsea and Blake, and I've just used the initial from each of those names. And they each run a lap, and these are the times they take to run them. So the question is a common one where it'll ask, how long after they start the race will they cross the finishing line together, okay? So they're going round and round and round. Really what we're looking for here is what is the lowest common multiple of these three numbers, okay? So if we look at this as a worked piece, we can have it's multiples of 4, 3 or 6, okay? So we just get rid of that. We'll just use the ends in here. So it's 4, 3 and 6, and we just do multiples of those, okay? So what we're looking for here is a number that all of them will go into, okay? So it's 4, 8, 12, 3, 6, 9, 12, 6 and 12. And so you can see that 12 is common to all three, and it's the lowest one that's common to all three. So it's at the 12-minute mark that they will cross the start line together again. Now the race itself goes for 36 minutes. Okay, and so what we're looking for here is how many laps each of them will complete. So to calculate how many laps they'll complete, it's just a case of doing a simple division, okay? In 36 minutes, Michael will do, okay, 9 laps, okay? Chelsea will do, divided by 3, she will do 12 laps. And Blake will do 6 laps. So that's the number of laps each of them will complete in that 36 minutes, okay? So that's pretty straightforward, okay? And then finally it asks Chelsea is going to overtake Michael, okay? So how many times does that occur, okay? So this then goes back to our multiples type scenario. So it's going to be, Chelsea's going to be 3, 6, 9, 12, okay? Now we know that's a multiple, okay? So then the next multiple of that will be at 24, okay? Now, just I suppose to be clear on that, 4, 8 and 12, that's the first time she passes him, okay? Now, the next time will be at 24, so we know that. Now, some of you will argue, well, what about at 36, okay? Well, that's when they both finish the race. So at that moment, they're passing the line together, but one person is not actually overtaking the other because the race is finished at that point, okay? So there's no moment where the other person is actually in front. So the 36 doesn't count, okay, in this particular instance, even though they would get to the line at the same time. Okay, this question is, it's a little bit wordy, okay? So you've got to read it really quite accurately because it asks about remainders, okay? And so what it's asking you is that Marcus has got these 3 sets of berries and he's going to share them with himself and his 2 friends. So he's going to share them into 3 equal groups. So really what's asking you then is to divide each of them by 3. So you're going to go 3 into 98, 3 into 133, and 3 into 63. And then it's going to ask you how many remainders are left. So when you do the is, you're going to end up with a remainder at the end of it, okay? Now, we don't know if you're going to have a remainder, but that's the one we're looking for. So if we work out this for strawberries, so 98 strawberries, 3 into 9 goes 3 times, 3 into 8 goes twice, with remainder 2. So we know that in the leftovers, there's going to be 2 strawberries. Okay. Then 3 into 1 goes 0 times, 3 into 13 goes 4 times with 1 left over, okay? And 3 into 13 goes 4 times with 1 left over, so there's going to be 1 blueberry. And finally, 3 into 6 goes twice, 3 into 3 goes once, so there's going to be none. So there's going to be no gooseberries. Okay, so the question asks how many of each type are going to be in the remainder, and the answer is 2 strawberries, 1 blueberry, no gooseberries in the remainder that are left over. Part 2 of this question says, is it possible to divide the berries evenly into a certain number of groups and have exactly no remainder of any type of berry? What is the largest number of groups where this occurs? Okay. So the easiest thing to do here is to look at the smallest number, okay, 63, and let's look at the factors of 63 firstly, okay? So we have 7 nines are 63, okay? So it's clearly 7 and 9, okay? And so if 9's one of the factors of it, then 3 is definitely one of the factors of it, okay? And then we can look at 3 goes into that 21 times, okay? And then that's 7 and 3. I think that might be about it. So they're only the factors here. So now we can look at these and go, okay, which one of these will go in? Now, we've already used 3. Okay, we did that in the previous question and we know that there were some remainders. So let's go to the next biggest, which is 7. So let's divide 63 by 7. Okay, and see what answer it gets to see if there's a remainder. Okay, well, it shouldn't be because it's one of the factors. Okay, so 7 goes into 63 9 times. Okay, no remainder. So let's try with blueberries. 133 divided by 7. Okay, do a little sum over here. 7 into 133. Now, straight away I look at this and I go, well, I know 7 goes into 140. Okay, because 7 times 2 is 14, 7 times 20 is 140. So it's going to go into that because that's going to be 1 less. It's going to go in 19 times. Okay, so this is looking good so far. Okay, and then finally, 98. Okay, divided by 7. Okay, now to do divisibility of 7, we simply have to go, we go 98, take away 70, because we know 7 tens are 70. And that leaves us with 28. Does 7 go into 28? Yes, it does. It goes in 4 times. So that's going to be 10 plus 4 is 14. So it goes in 14 times. So there's the 3 proofs that show that if we put them into 7 equal groups, 7, okay, equal groups, you will get all the berries are split up and no remainder for any one of them. Okay. Now, if 7 hadn't have worked, you could have gone back to 63 and gone, well, does 9 work, does 21 work, and you could have worked your way through each of those had 7 not been the one that was successful.